Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about introduction to fuel and combustion, classification of fuels, and what are the characteristics of good fuel and solid fuel, how can we analyze. So analysis of coal and proximate analysis and its significance. So these are the topics today we are going to discuss today's session. So first, what is meaning of fuel? So fuel is a basic combustible substance. Fuel is a basic combustible substance. It containing main constituent is carbon. Fuel is a basic combustion material or combustible substance. It containing main constituent is carbon. So during burning process, in the presence of oxygen, during burning of fuel, in the presence of oxygen, it produces heat energy. Is called fuel. So fuel is a combustible substances. It consists of basic constituent is carbon. So carbon is the main constituent of fuel. So which on burning gives large amount of heat during the process of combustion of a fuel. So that can be used for domestic and industrial purpose. So fuel is a basic combustible substance. So what is the meaning of combustion? During burning process, it is a process of burning of fuel in the presence of oxygen. So this process is called combustion. So fuel is the basic combustible substance. It containing main constituent is carbon. So during burning process, fuel in the presence of oxygen, it produces heat energy. So this energy used for domestic and industrial purpose is known as fuel. So the atoms of carbon, hydrogen, sulfur, etc. So the atoms of carbon, hydrogen, sulfur, etc. combine with oxygen during burning process with simultaneous liberation of heat is known as fuel. So generally fuel, it contains main constituent is carbon, and also it's present sulfur, hydrogen, oxygen, etc. also present in fuel. So during burning process, these elements which are present in fuel like carbon, hydrogen, sulfur, etc. Combined with oxygen, simultaneous liberation of heat is known as fuel. It produces heat energy. General concept is fuel when it is reacts with oxygen or oxidation products, then it produces during heating process it produces combustion products and energy. So fuel burning in the presence of oxygen, it produces combustion product and also release energy, heat energy. So this energy is used for domestic as well as industrial purpose also. So for example, in this fuel it's present carbon. If in case fuel, in this fuel it's present carbon. So already we know the fuel, it contains main constituent is carbon. So during burning process, if in case carbon present in this fuel, so it reacts, it combines with the oxygen, then it produces combustion product is carbon dioxide and it releases 94 kilocalories of heat energy. It releases 94 kilocalories of heat energy. And next one, if in case hydrogen present in this fuel, so during burning process in the presence of oxygen or during burning of fuel, if in case hydrogen present in that fuel, hydrogen combines with oxygen, then produces combustion product is water. It releases 68.5 kilocalories of energy, heat energy. So this energy is generally used for domestic and industrial purpose. So generally the main source of fuel is coal and crude petroleum oil. The main source of fuel is coal and crude petroleum oil. So these are stored fuels available under the earth crust and are generally called as fossil fuels. The main source of fuel is coal and crude petroleum oil. So these are stored fuels which are available under the earth crust. So generally named as fossil fuels. So because they were formed from fossilized the remains of plants and animals. So simply we say the plants and animal materials buried under the earth crust in a million of years, the absence of air. So in this case, it converts to the fossil fuels. So the main source of fuels is coal or crude petroleum. So these are stored fuels which are available under the earth crust is generally called fossil fuels. So fuel means during burning process, it produces heat energy in the presence of oxygen is known as fuel. So this energy is used for industrial and domestic purpose, and it containing basic constituent is carbon. Main constituent of fuel is carbon. What is the main reaction during burning process? Fuel, when it is reacts with oxygen in the presence of oxygen or oxidation products, then it gives combustion product and it will release energy. The main source of fuel is coal and crude petroleum. Generally, it is obtained from under the earth crust. So, in plants and animal materials buried under the earth crust in a million of years, reaction of heat and pressure and absence of air. So, in this case, it converts fuels is named as fossil fuels. Named as fossil fuels. They are the main source of fuels. Now, let's discuss what are the characteristics of good fuel. What are the characteristics of good fuel? So, the fuel should be easily available. The fuel should be easily available and it should be dry and should have less moisture content. Good fuel always contain low moisture content. If in case this percentage is high means calorific value decreases. It requires more heat for burning. So always good fuel it requires a low percentage of moisture content. So it should be dry and should have less moisture content. So dry fuel increases its calorific value. So what is the meaning of calorific value? So how much amount of heat required? 1 molar mass of fuel is burning. 1 kg of fuel burning. If in case, in this case, how much amount of heat liberated during 1 unit mass of fuel is burning. So that value is known as calorific value. So good fuel always it contains it produces high calorific value. If in case moisture content present in that fuel, it reduces the calorific value. So always good fuel contains low percentage of moisture content, and it should be cheap and easily transportable and has high calorific value. Always good fuel it is available in less cost, so easily transportable, easily we can carry, and it has high calorific value. Heat energy liberated it is also very high in this good fuel, and it must have moderate ignition temperature. It must have moderate ignition temperature and should leave less ash after combustion. It should leave less ash after combustion. So always good fuel should have moderate ignition temperature, and the combustion speed of good fuel should be moderate, and it should not burn spontaneously. So to avoid fire hazards, it should not burn spontaneously. So in this case, to avoid fire hazards, and its handling should be easy and should not give poisonous gases after combustion. After combustion, it does not produce any harmful or poisonous gases. And the combustion of good fuel should not be explosive. These are the main characteristics of good fuel. Main characteristics of good fuels are generally easily available, easily we can transport it, and should have low moisture content, low volatile matter, low ash content. Because if in case this percentage increases in this fuel, the moisture content, volatile matter, ash content, if in case these percentages increases in this fuel, so it reduces the calorific value. So always good fuel is having high calorific value. Calorific value means how much amount of heat liberated when a unit mass of fuel is burning. So always good fuel containing high percentage of moisture content, volatile matter, ash content, and also it is having high calorific value, and it is available in less cost, eco-friendly. That means do not produces any poisons or harmful gases during burning or after combustion process also. and the combustion of a good fuel should not be explosive. So these are the main characteristics of good fuel. Now let's discuss classification of fuels. So fuels, generally fuel means it is a basic combustion material and it containing main constituent is carbon. So during burning process in the presence of oxygen, it produces heat energy that is used for domestic and industrial purpose. So that is called fuel. So this fuel is classified into two types, primary fuels or secondary fuels. So primary fuels, it is also called as natural fuel. These primary fuels are also called as natural fuels. And next second one is secondary fuels. It is also called as artificial fuels. Secondary fuels, it is also called as artificial fuels. Again, this primary and secondary fuels classified into three types: solid fuels, liquid fuels, gaseous fuels. So best example of solid primary fuel is wood or coal. Wood and coal. And second one is liquid fuels of natural fuels. Best example is petroleum. And gaseous fuels best example is natural gas. And secondary fuels or artificial, it is also called as artificial fuels. Again, these fuels also classified into three types: solid, liquid, gaseous fuels. So solid fuel best example charcoal, liquid fuel petrol or diesel, gaseous fuel coal gas or water gas, etc. So fuels are classified into two types: natural fuels, primary or primary fuels. Second type is secondary fuels or artificial fuels. So natural fuels generally obtained from nature. Generally obtained from nature. Secondary fuels, these are also called as artificial fuels. These are obtained from primary fuels. So that's why these are called synthetic fuels, or that means artificial fuels. So again, these primary and secondary fuels classified into three types: solid, liquid, gaseous fuels. So now let's discuss this detailed discussion of classification of fuels. So on the basis of occurrence, so these fuels are classified into two types: primary fuels, or it is also called as natural fuels. So these are found in nature. These are found in nature. For example, such as wood, peat, coal, petroleum, natural gas, etc. These all are called best example of primary fuels, or it is also called as natural fuels, which are in obtained from nature. And second one is artificial or secondary fuels. Secondary fuels or artificial fuels. So these are prepared artificially from the primary fuels. These are obtained from primary fuels. They are prepared artificially from the primary fuels. For example, charcoal, coke, kerosene, diesel, petrol gas, coal gas, petrol, oil gas, producer gas, blast furnace gas, etc. These all are the best example of secondary fuels which are made from this primary fuels, artificially prepared from primary fuels. So again, this both primary and secondary fuels further subclassified into two types based on their physical state. These primary and secondary fuels may be further subclassified based on their physical state. Based on physical state, so these primary and secondary fuels again subclassified into three types. So what is that? Solid, liquid, and gaseous fuels. So based on physical state, so these primary and secondary fuels are classified into three types: solid fuels, liquid fuels, and gaseous fuels. So now let's discuss solid fuels. So primary solid fuel best example is coal. So coal is important primary solid fuel. Coal is important primary solid fuel. So which was formed under earth crust. Which was formed under earth crust from the plant and animal material. From the plants and animal material by partial combustion under high pressure and in the absence of air through millions of years. Then form this coal. So how can we form this solid fuels or coal? Solid fuels, best example is coal. The coal is the best example of primary solid fuel. How to form this coal? So plants and animal materials buried under the earth crust in millions of years under high pressure. The partial combustion under high pressure in the absence of air through millions of years, then converted to fossil fuels or coal. So the following flow diagram involved in this, how to convert wood into coal. So first form is wood, then it converted into peat, then lignite, then bituminous coal, and final form of coal is anthracite coal. This is the usage form of coal is anthracite coal. So from wood, you see the image here, how to convert, what are the phase involved in this formation of wood into coal. So first form is wood, then converted into peat, after that lignite, then bituminous coal, and finally anthracite coal. So from wood to anthracite coal, moisture content, volatile matter, and hydrogen, oxygen, nitrogen, sulfur content decreases. From wood to coal, from wood to anthracite coal, moisture content, volatile matter, hydrogen, oxygen, nitrogen, and sulfur content decreases, and carbon content and hardness, calorific value increases. From wood to anthracite coal, this moisture content, volatile matter, and these elements like hydrogen, oxygen, nitrogen, sulfur, this percentages decreases, and carbon content and hardness and calorific value percentages increases. So how much percentage of present this moisture, carbon content, hydrogen content, and calorific value, how much percentage present in this conversion of wood to coal, anthracite coal. So first one is percentage of moisture content. So generally this classification of coal, so based on that moisture content, carbon content, hydrogen content, and calorific value. So how much percentage present in this coal? So generally coal is classified into 5 ways. And the first one is, first form of coal is wood, then peat, lignite, bituminous coal, and anthracite coal. So first one is wood. So how much percentage of moisture content present in this wood? 25. In peat, 25%, lignite 20, and bituminous coal 4, and anthracite coal 1.5. So what we observed in this, so from wood to anthracite coal, the percentage of moisture content is decreases. Percentage of moisture content is decreases. From wood to coal, the percentage of moisture content is decreases. And second one is carbon content. So carbon, wood containing 50% of carbon, and peat it contains 57, lignite 60 to 80% of carbon, and bituminous coal 83, and anthracite coal is 93.3. So what we observed in this, from wood to coal, the percentage of carbon, increases. From wood to coal, this percentage is increases. And next third one is percentage of hydrogen content. Hydrogen content. So in this wood it can present 6%, in peat 5.7, and lignite 5, and bituminous coal 5, anthracite coal is 3. So in hydrogen content, from wood to coal, anthracite coal, the percentage of hydrogen is decreases. Hydrogen percentage is decreases. And finally, calorific value. Calorific value. So its value, calorific value means how much amount of heat liberated during 1 unit mass of fuel burning. It is important. So if a good coal always containing high percentage of calorific value. So in this conversion wood to anthracite coal, how much percentage of calorific value present in this, we'll discuss now. So wood, it relates 4,000 to 4,500 calorific value. And in this peat, 4,500 to 5,000 kilocalories of heat energy liberated. And in this lignite, it produces 6,500 to 70,000 calorific value heat energy liberated. And bituminous coal, it produces 8,100 to 8,600 calorific value produces. And here anthracite coal calorific value 8,650 to 8,700. So what we observe from wood to coal, the calorific value percentage is increases. Calorific value percentage is increases. So classification of coal, that means this can be classified. What are the steps involved in this conversion of wood into anthracite coal? So first wood convert to peat, then lignite, then bituminous coal, and final form of usage of coal is anthracite coal. So in this case, how much moisture content from wood to coal, this percentage is decreases. So always good coal contains less percentage of moisture content, and here also from wood to coal, the moisture content is decreases. The wood contains more percentage of moisture content compared to anthracite coal. And second one is carbon content. So carbon content here wood to coal, this percentage is increases. Always good coal, it contains high percentage of carbon content because carbon is the main constituent of fuel. It increases the calorific value. So from wood to coal, this carbon percentage increases. And third one is percentage of hydrogen content. So from wood to coal, the percentage of hydrogen also decreases. So always good coal contains less percentage of hydrogen because it reduces the calorific value. So from the wood to coal, the percentage of hydrogen also decreases. And finally, calorific value. So here calorific value also increases the efficiency of fuel. So always good coal contains high percentage of calorific value. So from wood to anthracite coal, this percentage increases. So moisture content and hydrogen content is decreases from wood to anthracite coal, and carbon content and calorific value percentages are increases in this wood to coal conversion, anthracite coal. Now let's discuss comparison between solid, liquid and gaseous fuels. So here first we discuss calorific value. So what are the comparisons between solid, liquid, gaseous fuels? Generally, fuels are classified into two types. Just now we discussed already, primary fuels and secondary fuels. So based on physical state, again these fuels are subclassified into three types: solid fuels, liquid fuels and gaseous fuels. So how can we define, how can we compare between the solid and liquid gaseous fuels? So first one is based on its calorific value. So in the solid fuels, the calorific value is low. In the solid fuels, the calorific value is low. But in this liquid fuel, this calorific value is high. And in the gaseous fuel, this calorific value is highest compared to solid and liquid. So in this, based on this calorific value, in the solid fuel, the calorific value is low, but liquid and gaseous fuels, this value are high. And pollution. So their ash content is high in the solid fuel. Their ash content is high and it produces lot of smoke on burning because it contains high percentage of ash. So if in case ash percentage increases in this fuel, it produces more smoke. So that's why here their ash content is high and they produces lot of smoke on burning. It produces lot of smoke on burning. Here in this, coming to the liquid fuels, their ash content is low. Their ash content is low and they burn without smoke. They burn without smoke. And in this gaseous fuel, they are almost pollution free. They are almost pollution free. So they burn without smoke and ashless. They burn without smoke and ashless. So in the solid fuels, it produces more smoke because it contains high percentage of ash. But in this liquid fuels, their ash content is low and they burn without smoke. And here in these gaseous fuels, they are almost pollution free. They burn without smoke and ashless. It doesn't contain any ash. But in this liquid fuel, it contains less percentage of ash. But in this solid fuel, it contains more percentage of ash. That's why it produces more smoke on a lot of smoke on burning. And third one is ignition temperature and fire hazards. Ignition temperature and fire hazards. So in this solid fuels, there poses moderate ignition temperature. In this solid fuels, it having moderate ignition temperature. Here in this liquid fuel, the ignition temperature is low. Their ignition temperature is low. So there is chance of fire hazards. It will be chance for fire hazards because its ignition temperature is low. And in these gaseous fuels, they are having very low ignition temperature. They have very low ignition temperature. So they are highly inflammable. They are highly inflammable. And chance of fire hazards is highest. The chance of fire hazards is highest. So next one is cost. So the production cost is low. Here in this solid fuel, the production cost is low. But in this liquid fuel, cost is relatively higher than solid fuels. Comparatively solid fuels, liquid fuels are high cost. And gaseous fuel, they are more costly compared to solid liquid fuels. So what are the comparisons between solid and liquid gaseous fuels? First one is calorific value. In the solid fuel, it produces low calorific value compared to liquid and gaseous fuels. Gaseous fuels are produce more calorific value compared to solid and liquid. And second one is pollution. And the solid fuels produces more smoke. It causes pollution during burning because it is having high ash percentage. But liquid fuels, it is having less percentage. So it produce, but they burn without smoke. It contains very less percentage of ash, but they burn without smoke. In gaseous fuels, it completely pollution free because it doesn't contain any ash. So it doesn't produce any smoke during burning process. And ignition temperature and fire hazards. So in the solid fuels, it poses moderate ignition temperature. There is no fire risk, fire hazards. But in liquid fuels, in its ignition temperature is low, so there is a chance for fire hazards. But in gaseous fuels, there is very low ignition temperature, so they are highly inflammable and chances of fire hazards highest rate compared to solid liquid. And next one is cost. Compared to liquid and gaseous fuels, the solid fuels available less cost. But is liquid fuels are cost relatively higher than solid fuels, but lower than gaseous fuels. And in gaseous fuels, they are more costly compared to solid liquid fuels. Solid liquid fuels. And next comparison is transportation. So in these solid fuels, they are easy to transport. They are easy to transport through normal carriage. So cost is low. Easily we can transport these solid fuels. So cost is low compared to liquid and gaseous fuels. But in this liquid fuel, they can be transported. They can be transported through pipelines. Hence, it is more costly. So this in this liquid fuels, they can be transported through pipelines and hence it is more costly. Coming to gaseous fuels, they can be conveyed through pipelines. They can be conveyed through pipelines. So hence obviously it is costly. It is costly. So compared to liquid and gaseous fuels, solid fuels are available in very less cost. It is easily transported. It takes less cost. So next is storage. So in the solid fuels, the storage needs lot of space. Storage purpose it takes lot of space, but there is no risk. There is no harmful. There is no risk. But in this liquid fuel, it is costly, and here special storage tank is required for storaging. special storage tank is required for storing, and safety precautions has to be taken to prevent fire hazards. So as most of them are highly inflammable and volatile. So in this liquid fuel is costly. These are costly. Special storage tank is required for strong and safety precautions has to be taken to prevent fire hazards. As most of as them are highly inflammable and volatile. And here gaseous fuels they can be compressed in cylinders. They can be compressed in cylinders. So storage does not need lot of space. So storage purpose it requires very little space because gas is compressed and stored in the cylinders. So safety precautions has to be taken to prevent fire hazards. They are highly inflammable and volatile. So these are the main comparisons between solid, liquid, gaseous fuels. Solid, liquid, and gaseous fuels. Now let's discuss analysis of coal. How can we analyze this coal? So to fix the price and its specific industrial applications, coal is analyzed following two methods. Generally, what purpose we analyzed coal? So it is most important analysis of coal because it fixes the price and quality and which type of coal is suitable for some special industrial application point of view. Which coal is suitable for industrial application purpose. So that purpose analysis of coal is most important process. So this coal is analyzed by following two different methods. One is proximate analysis and another one is ultimate analysis. So proximate analysis, it is mainly used for it. In this process, we can analyze, fix the price and quality. To fix the price and quality, it can be analyzed by proximate analysis. In ultimate analysis, which type of coal is suitable for some special industrial application purpose. So which type of coal is suitable for industrial application purpose? It can be analyzed by ultimate analysis. So analysis of coal is most important because to fix the price and quality and suitable specific industrial application purpose which coal is suitable. So this can be analyzed by following two different types of methods. So that is one is approximate analysis and second one is ultimate analysis. So first method is proximate analysis. So what is the use of proximate analysis? What we can analyze in this proximate analysis? So it helps to fix the quality and price of the coal. To fix the price and quality of the coal. So it involves determination of percentage of moisture content, volatile matter, ash content and fixed carbon in a coal. So this proximate analysis mainly used for to fix the price and quality of coal. So in this case, what we can analyze, what we have to analyze in this coal sample, moisture content, volatile matter, ash content, and carbon percentage in coal, fixed carbon in coal. So these are you can analyze in this proximate analysis for what purpose? To fix the price and quality of coal. So now let's discuss how can we determine the moisture content present in coal sample. So here 1 gram of finely powdered coal sample. Here, see here. So 1 gram of finely powdered air dried coal sample taken in crucible. This is a crucible. This is the hot air oven and this is the desiccator. This is a desiccator. This is crucible, coal sample. What we have to find out in this proximate analysis that coal sample taken in this crucible, heating in this muffle furnace and weigh it again after heating, weigh out in this by taking this desiccator. So how can we calculate moisture content present in coal sample? So 1 gram of finely powdered coal sample, 1 gram of powdered air dried coal taken in crucible. Taken in crucible. 1 gram of finely aided coal sample taken in this crucible. Weigh out this coal sample 1 gram by using weighing machine. So 1 gram of finely powdered air dried coal taken in this crucible, weighed first. So the crucible is heated in this temperature range is 105 to 110 degrees centigrade. 105 to 110 degrees centigrade. The crucible is heated at 105 to 110 degrees centigrade for 1 hour. For 1 hour in electrical furnace or hot air oven. So if in case moisture present in coal sample, so that can be evaporate. If in case moisture present in the coal will evaporate. So then this crucible is cooled in air, then it is in desiccator and weighed again, weighed out again. So the loss in weight expressed as the percentage of moisture present in coal sample. So can you determine moisture content present in coal sample? First weigh out 1 gram of finely powdered air dried coal sample taken in crucible and heating in hot air oven or electrical furnace or muffled furnace. And here maintaining temperature range is 105 to 110 degrees centigrade for 1 hour. After that, so in this case, if in case moisture present in this coal sample, so during heating process it will be evaporate. It will evaporate. Then crucible is cooled in air. Crucible is cooled in air. Then in desiccator. So in weighed again. So what we observed, what happened here? So last coal sample weight is decreases. So the loss in weight expressed that the percentage of moisture present in coal sample. The percentage of moisture present in coal sample. So how can we determine what is the formula we are using here? So percentage of moisture in a coal is equal weight of crucible after heating. So what we observed after heating means weight loss. So the weight loss in weight expressed as the percentage of moisture present in coal sample by weight of crucible before heating. Before heating. So for example, we are taking 1 gram of fine air dried powder coal sample taken in crucible. So that is the weight before heating means. After heating means after heating we already observed weight loss. Loss in weight expressed as the percentage of moisture present in coal sample into 100 into 100. So weight of crucible after heating by weight of crucible before heating into 100. In this way, you have to calculate the moisture content present in coal sample. And second one is volatile matter. So after the analysis of moisture content, after the analysis of moisture content, the crucible with residual coal sample is same coal sample taken for testing this. So after comparing this moisture content, so same the crucible with residual coal sample, it is covered with a lid. So the crucible containing residual coal sample, so this crucible is covered with lid. So and is heated at 925 plus or minus 20 degrees centigrade. And here heated in this muffled furnace. Duration time is 7 minutes. But in moisture content, we are maintaining temperature is 105 to 110 degrees centigrade for 1 hour. In this volatile matter determination purpose, after completing this moisture content, the crucible is crucible with residual coal sample is covered with lid. Heated at muffled furnace, maintaining temperature range is 925 plus or minus 20 degrees centigrade for 7 minutes. For 7 minutes. So here what we observe, the loss in weight of the sample. The loss in weight of the coal sample is find out of the percentage of volatile matter present in coal sample. Loss in weight of coal sample is expressed as the percentage of volatile matter present in coal sample. So here, after completing this volatile moisture content, same crucible with residual coal sample closed with the lid, heating in muffled furnace, maintaining temperature range is 925 plus or minus 20 degrees centigrade for 7 minutes. So in this case, after heating, what we observe, the loss in weight of coal sample. It is expressed as the percentage of volatile matter present in coal sample. So how can we determine what is the formula we are using here for determination of volatile matter? The percentage of volatile in coal is equal weight of crucible after heating in the step 2. Step 2 means volatile matter. So weight of crucible after heating by weight of crucible before heating from the step 1 into 100 into 100. So by using this formula, we have to calculate the volatile matter present in coal sample. Next, third one is ash content. So after the analysis of volatile matter, so the crucible with residual coal sample, heated without lid at 700 to 750 degrees centigrade. At 700 to 750 degrees centigrade for half an hour in a muffle furnace. So after the analysis of volatile matter, same crucible with residual coal sample and without lid. In volatile matter, we covered with lid, but in this ash content, we remove that lid. After completing this volatile matter, the crucible with residual coal sample without lid, heating at electrical furnace or muffle furnace, we are maintaining temperature ranges 700 to 750 degrees centigrade for half an hour. So in this case also we observe loss in weight of coal sample. So that is expressed as the percentage of ash content in coal sample. The loss in weight of coal sample, it is expressed as the percentage of ash content present in coal sample. So how can you calculate the percentage of ash present in coal sample? So percentage of ash content in coal sample is equal weight of crucible after heating in the step 3. Weight of crucible after heating in the step 3 by weight of crucible before heating. Weight of crucible before heating into 100. So by using this formula, we can calculate the ash percentage present in coal sample. And last one is fixed carbon. So already we know that carbon is the actual combustion. Main constituent of fuel is carbon. So carbon is the actual combustible material in the coal. So greater the percentage of fixed carbon, more will be the calorific value of the coal. So already we know that main constituent of fuel is carbon. Carbon is the main constituent of fuel. So if in case carbon percentage increases in this fuel, it increases the calorific value. So that fuel is having high calorific value means it is a good fuel. It is also suitable for industrial application and most demanded fuel also. So greater the percentage of fixed carbon, more will be the calorific value of the fuel. So how can you determine the fixed carbon percentage in this fuel? So it is determined by subtracting the total of moisture, volatile and ash content from 100. So what is the formula we are using here? Percentage of fixed carbon in coal is equal 100 minus percentage of moisture content plus volatile matter plus ash content. So in this way, you have to calculate the carbon percentage present in coal sample. If in case this percentage increase in this fuel, it acts as a good fuel and it increases the calorific value. Now let's discuss what is the significance of proximate analysis. So already we know that what is the use of proximate analysis? To fix the price and quality of coal. So it is helpful in fixing the price of the coal and its quality also. To fix the price and quality of the coal, it can be determined by using this proximate analysis. So what is the significance? In this determination purpose, generally we determined already, just now we discussed moisture content, volatile matter, ash content, fixed carbon. Already we determined. Now let's discuss what is the significance of proximate analysis. So first one is moisture content. If in case high percentage of moisture present in coal sample. So in this case, it is highly undesirable. It is highly undesirable because it reduces the calorific value of the coal. If in case percentage of moisture content is increases in this fuel, it is undesirable because it reduces the calorific value of the coal. And second one is moisture in coal consumes more heat and increases ignition temperature and smoke also. So that means excess heating is required to evaporate the moisture. It requires more heating, more heat requires for burning process and reduces more smoke and it increases the ignition temperature also. It causes fire hazards mainly. So moisture content, if in case high percent present in coal, that coal is undesirable because it reduces the calorific value, and if a moisture in coal, it consumes more heat and increases ignition temperature and smoke. Simply we says heat, it requires more heat, excess of heating is required to evaporate the moisture content present in coal sample. So hence, what is the main point? The coal with less moisture content is considered as best coal, good coal. Good coal always contains less percentage of moisture content. And next one is volatile matter. So high percentage of volatile matter is undesirable. High percentage of volatile matter is undesirable because it is also reduces the calorific value of the coal. It reduces the calorific value of the coal. And the coal with high percentage of volatile matter burns with a large flame with high smoke. If in case this volatile matter percentage increases in this coal, it produces more smoke. It requires more heat energy. I do not support the burning, incomplete burning. It does not support the burning process also. So high percentage of volatile matter present in coal sample. In this case, this coal is undesirable because it reduces the calorific value and it burns with a large flame with high smoke. That means do not support the burning. So hence it tells that coal with high percentage of volatile matter is not a good coal. That means always good coal contains less percentage of volatile matter. Always good coal contains less percentage of volatile matter. And third one is ash content. High percentage of ash content. It is also undesirable. It is also undesirable because ash reduces heat retention capacity. Ash reduces heat retention capacity and calorific value of the fuel also reduces. More ash, if in case present in this fuel, it is also highly undesirable because incomplete burning of fuel because incomplete burning of the fuel and formation of clinkers, that means hard or non-disposable waste form, and increased cost of transportation and storage. Increase cost of transportation and storage, it produces more smoke also. If in case ash percentage increases, may it do not support the burning and it produces more smoke and it reduces calorific value. And next one, fixed carbon. So already we know that carbon is a main constituent of fuel. It is a basic combustible substance, combustible material in this fuel. So always good fuel contains high percentage of carbon because it increases the calorific value. So here high percentage of fixed carbon is desirable. High percentage of fixed carbon is desirable because high the percentage of fixed carbon in coal, greater the calorific value. It increases the calorific value. It's the main character of coal. Always good coal contains high percentage of calorific value. It produces more heat energy and low smoke moisture content also, and high heat capacity and low volatile matter. Okay, So always good coal contains low percentage of moisture content, low percentage of volatile matter, low percentage of ash content, high percentage of fixed carbon. Because if carbon percentage increases means it increases the calorific value. If in case the remaining volatile matter, moisture content, ash percentage increases in the fuel, it reduces the calorific value. It requires more heat energy. It do not suppose the burning. It produces more smoke. So that's why always good fuel contains a low percentage of moisture content, volatile matter, ash content, and high percentage of fixed carbon. So in this session, already we learned what is fuel, how many types of fuels, what are the characteristics of fuels, and also we discussed analysis of coal. So there are two types of analysis methods, proximate analysis and ultimate analysis. Today's session already we learned proximate analysis. So what is the use of proximate analysis? To fix the price and quality of coal. So in this purpose, what we can analyze in this method, moisture content, volatile matter, ash content, and fixed carbon. And the significance also we discussed already in this session. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.